The process to sketch the inverse sign is similar to the process we use to sketch logarithms, right? Remember when we were sketching e to the x, we had our system, and then for logarithms, we rewrote them and we used y instead of x, right? Because they're inverses of one another. And it's the same thing here. So what I have here is, I'm just going to write this as, in the other notation, as y equals inverse sine of 3x. So I haven't changed anything at all. I just wrote arc sine as sine to the power of -1. Now, I can solve this for x. The way I can do that is, I can take the sine of both sides of this. When I do that, I get that sine of y is equal to 3x, so x is equal to 1 over 3 sine of y. Okay? Now, let's talk about domain and range. In the chart right up here, we said that the domain for the arc sine is from -1 to 1, right? So what we're going to do is something very similar to what we did before. We're going to say, okay, -1 less than or equal to 3x less than or equal to 1. So this will be -1 over 3 less than or equal to x less than or equal to 1 over 3. So my graph is going to go between -1 over 3 to 1 over 3. For the range, this is the domain. So the domain of the regular sign gets restricted from negative to positive pi over 2. But when we say inverse sign, the domain becomes the range. So the range becomes negative pi over 2 to pi over 2. So the range now is negative pi over 2 to pi over 2. Okay? Now, here's how I'm going to graph this. I'm going to make a chart. I've found this is a lot easier than other methods. I'm going to make a chart, and I have x and y, except just like for the logarithm, instead of picking points for x, I'm going to pick points for y. Okay? So y is the range. It goes between negative pi over 2 to pi over 2. All right? Huh? Right, the midpoint is 0. But so basically the range, the y values are going to go between negative pi over 2 to pi over 2. Okay? Now let's split this up into the 4 quarters. Exactly in the middle is 0. The first quarter here is negative pi over 4 and pi over 4. Does everybody see how I did that? It's just like what we were doing before. Okay, so now I'm going to plug in my y values into my expression and get my x values. Okay? So what is x? We solved for x and we got 1 over 3 sine of y. So x is 1 over 3 sine of negative pi over 2. So this is 1 over 3 times, what's sine of negative pi over 2? -1. Good job. Okay, so -1. So this answer here is -1 over 3. So when x is -1 over 3, y is negative pi over 2. You see how that works? All right, so one more. X is equal to 1 over 3 sine of negative pi over 4. And we know that for the pi over 4s, it's the 45 degrees. The legs are always root 2 over 2, right? So at negative pi over 4, this is the 4th quadrant, is sine positive or negative? So negative. So this is going to be 1 over 3 root 3 times root 2 over 2, which is root 2 over 6. Negative. Okay? Now, next we have 1 over 3 sine of 0. What's sine of 0? 0. Next I have 1 over 3 sine of pi over 4. So now this is 1 over 3 times positive root 2 over 2. Root 2 over 6. And finally, 1 over 3 sine of pi over 2, 1/3. Okay? So now I'm going to graph my x and my y. When x is negative 1 over 3, okay, y is negative pi over 2 here. Okay? When x is negative 1 over 3, y is negative pi over, yeah, it's the other way, all right? It's the inverse. So now, let me do the end points first and then the half point. When x is 1 over 3, y is positive pi over 2 here. Okay, I'm doing the easy ones first. And then the very middle, x is 0, y is 0. Now I have at y, when y equals negative 4, a negative pi over 4, x is negative root 2 over 6. So how much is negative root 2 over 6? Can you plug it in and tell me how much negative root 2 over 6 is?
It's 0.2357.
Yeah. So it's 0.23, right?
Yeah.
Where is that? Well, this is negative 1 over 3, which is 0.33. So it's somewhere over here, right? So at negative pi over 4, we're here. At positive pi over 4, we're here. And my graph looks like this.
How many points do we have?
Okay? It's always like label. This is fine.
Do we have
So do we need, we don't need to, do we need to do?
For inverse tangent, what is the domain? No, negative infinity to infinity. So remember for tangent, the domain, all right, so the range is negative pi over 2 to pi over 2. And remember, it's going to be in open parentheses because you have asymptotes there. Okay, so let's rewrite this now. Y equals inverse tangent of x over 2. You take a tangent of both sides. Okay, so what you have is tangent of y is equal to x over 2, which is just half x. You multiply both sides by 2, so 2 tangent of y equals x. And we're going to do the same thing. We're going to pick our y values, and they're going to go from negative pi over 2 to pi over 2 again. So the middle is 0. And the quarters are negative pi over 4 and positive pi over 4. Okay? Now, x we said was 2 tangent y. So x is 2 tangent negative pi over 2. What's tangent at negative pi over 2? The coordinate is 0 and negative 1. What's the tangent? What's y over x? Undefined. Does that make sense? What? Because there is an asymptote at pi over 2. When y equals pi over 2, there is no x. There is an asymptote. Awesome. Isn't that beautiful how it works out? It's so beautiful. Okay, so x is 2 times tangent negative pi over 4. What's tangent of the over 4s always? 1. And at negative pi over 4, it's negative 1. So this is negative. Huh?
Negative pi over 4 is 1. Because they're both negative. It's quadrant 4.
No. Cosine is positive.
So in quadrant 4, tangent is negative.
Oh, yeah.
Okay. You're taking your test today then?
Yeah.
Okay. X equals 2 tangent of 0. 2 tangent of 0, which is 0, right? Here, x equals 2 tangent pi over 4. No, pi over 4, we get tangent of pi over 4 is 1, so it's 2. And here, this one's undefined. Tangent of pi over 2 is undefined, asymptote. Now, when x is negative 2, y is negative pi over 4 here. At x is 0, y is 0, and at x equals 2, y is pi over 4. And there we go. That's how that looks. And this is how you graph inverse trig functions.
Cool, man.